Hello there, everybody. I'm Dr. Sasparilla, and I'm here at the Paleontological Institute for Dinosaurs, and oh my gosh, what if I got it wrong? Now, I was watching GL1's Lost episode where he was doing an experiment to try to determine if that model elephant over there was an accurate representation to scale for these sauropods. Well, it all depends on some assumptions you make, you see? And depending on what assumptions you make, you get different values. So I went through and I researched various researches on dinosaurs, getting different values for their size and using a different value for the size of the elephant. Now, what we're trying to do is stay within the normal range of an elephant, make a different assumption, and then compare those water weight displacements to our model. Well, GL1 made the assumption of an average African elephant at 9,000 pounds. But what if this is just no average elephant? What if this is a 15,000 pound male African elephant? Well, we end up with a different set of values. So over here I have this chart. Now, we have also made some different assumptions on the size of the dinosaur. You see, as you research, you can go on yourself on Wikipedia and you can go see other scientists and readings and stuff like that, such as this fellow here, Dr. Carl Bates, which I've worked together with very closely in 2015, where he came up with a different size for Dreadnoughtus. The Dr. Lakova, who discovered it from Drexel University, he came up with a different value, doing a different set of measurements. So let me demonstrate here. So let's assume the elephant 15,000 pounds, all right? And let's assume that Apatosaurus is 77,000 pounds instead of 39,000 pounds. The original measurement is what we used here, but there are some scientists that estimate that he's 77,000 pounds. And Brachiosaurus, 86,000 pounds instead of 82,000 pounds. And Dreadnoughtus we have here 130,000 pounds for Dr. Lakova's estimate, but we can find estimates around 108,000 pounds and even different than that. But we made that assumption there. Now, if you'll remember, this is the water weight displacement of each of these models here. We've got 3.4 pounds of water for that elephant there. 14.4 for the Apatosaurus, 20.2 pounds for the Brachiosaurus, and 21.8 pounds for our fellow here, the Dreadnoughtus. All right? Now, we're going to do a little bit of math here. Now, don't be scared. I'm going to explain it all. So, we're going to take that dino, all right? We're going to take that water weight in pounds, and we divide that by the dinosaur pounds of water weight, and we get these values here. We get a ratio for the Apatosaurus of 4.2, for the Brachiosaurus of 5.9, and for the Dreadnoughtus, 6.4. Now, keep in mind, that's just the ratio for the toys and their displacement of water. All right? Now, why we do that is most animals are made of water, mostly of water. So you can use water as a pretty good estimate for how much an animal might weigh. Now, let's take our revised value for the size of those dinos, and we're going to divide them by a 15,000 pound elephant. What we did over here is we divided them with a 9,000 pound elephant and different ratios, weights, for the size of the dinosaurs. But we're going to use these other weights here, all right, and we're in a larger elephant. So we divide the 77,000 pound Apatosaurus by the larger elephant, the 86,000 pound Brachiosaurus, and the 108,000 pound Dreadnoughtus. We're going to get different numbers here. Our ratios here are 5.1, 5.7, and 7.2. All right, now, that ratio is different than what we got over here, where we got 4.2, 5.9, and 6.4. So we got 7.2 versus 6.4, 5.7 versus 5.9, 5.1 versus 4.2. What does all that mean? What difference does it make? We're going to see what difference it makes, because now we have a new ratio of elephant to dinosaur. So we're going to use those ratios. We're going to take that water weight and we're going to divide that by our new ratio for the large dinosaur, in this case, divided by the larger elephant. We're going to get 0.82. Now, what does that tell us? Well, 0.82 of 100%. So there's an 18% difference in the ratio that we got between our actual weight of an apatosaurus and a larger elephant and our water ratio. It's an 18% difference. Now, in GL1's episode, he had a very small difference. He only had like a 2% difference. So this seems off, right? Right now it does seem off, all right? But then let's do the same thing with the Brachiosaurus. We're going to do the Brachiosaurus. We're going to take that ratio of the Brachiosaurus and we're going to divide, we're going to go into that, we're going to divide the water weight ratio by the dino ratio, dino to elephant ratio. We get a 3% difference. We get 1.03, 5.9 divided by 5.7. We get 1.03. Well, that's a 3% difference. It's 3% away from 100%. All right? And then we did the same kind of math here with Dreadnoughtus, and we ended up with a 13% difference. Now, those are very significantly different to what we got here in our original assumption. Sure, we had a 2% difference with the Apatosaurus, but we had a 35% difference on the Brachiosaur, and we had a 65% difference on the Dreadnoughtus. That's quite a big difference. So, I have those there. You can compare that right there. So, what does that mean? Does that mean that the old values were off and the new values are better? Or where does all this fall into place? Well, we take it up another level, another notch to understand where things can be. So, if you research on that internet various sizes, you can see that an Apatosaurus can weigh anywhere from 36,000 pounds to 77,000 pounds. So it's quite a bit larger, but that's the range that various scientists have discovered various models of them and studied them, and that's the range that they've come up with that it could be. And the range for the Brachiosaurus, 62 to 94,000 pounds. That's, again, a range, all right? And then we have the Dreadnoughtus as low as 68,000 pounds from that Dr. Carl Bates to 108,000 pounds that you'll see on Wikipedia, all right? Now, those are all different than our original estimates. Remember, we had 39,000 for Apatosaurus, 82,000 for Brachiosaurus, and 130,000 pounds for Dreadnoughtus. But let's see those are our ranges, right? Now those ranges, now again, we don't really know how much these dinosaurs weigh. What they do is they find the bones, they find a few bones, and they estimate on what they know from other dinosaurs and extrapolate out, and they'll take cross sections and measure and 3D it and everything and put it in the computer, and they come up with a value of what they think that dinosaur might weigh, right? But that's not exact because we don't really have the animal here, right? But that's why we have a range, and if we work with a range, we're going to get something different. So let's take that ratio, right? Let's take the exact ratio of water weight that we found for our model elephant to our model dinosaurs, and we're going to multiply that, right, by the 15,000 pound elephant. Now, why are we going to do that? We're going to go for zero difference, zero ratio difference. We're going to go to assume that the elephant weighs 15,000 pounds, and then we're going to say, we're going to assume for a second here that that elephant is an exact scale to these dinosaurs. What do we get for a value if we make that assumption? So we multiply that 15,000 pound elephant by the 4.2 pound ratio of water, we get 64,000 pounds for Apatosaurus. Does that fall within our ratio of 36 to 77? It sure does. And then we go 15,000 pounds elephant times our water ratio again. For Brachiosaurus, we get 88.5%. Yeah, I'm sorry, 88.5 thousand pounds. Does that fall within our range? 62 to 94? It sure does. And then we go again for the Dreadnoughtus, 15,000 pounds times 6.4 water ratio. We get 96,000 pounds. Now, it ain't that 130,000 pounds that Lakova thought, and it ain't exactly that 108,000 pounds that Carl Bates thought, but it definitely falls within the range of the 68 to 108, and there's a lot of controversy about the size of Dreadnoughtus especially, all right, because a lot of people like to say, I found the biggest dinosaur ever, so there's a lot of controversy about that. Well, we get 96,000 pounds for Dreadnoughtus. All of those fall within the range of the size of these dinosaurs. So what conclusion can we make on that? We can make the conclusion that that elephant, assuming it's 15,000 pounds African male elephant, is a realistic model scale to these sauropods. Because when you do the water ratios, you end up with a number, if you're going for no error, that falls within the range of these dinosaurs. And not only does it fall within the range, it's mighty close, actually, because if you'll see here, some assumptions for Brachiosaur are 86,000 pounds. Using our ratio method, we get 88.5. That's quite close. And we get 96K for Dreadnoughtus versus 108. That's right close too. And then we get here, now we get 64,000 for the Apatosaur. And, you know, that's a lot different than 39,000, but it's not that different from 77,000. Again, it's lighter. It's kind of like everybody can be happy. It's not quite too light, not quite too heavy. So I think that what we can do in the future is we can use that African dinosaur model to find out the scale of other dinosaurs, and then we can even scale those dinosaurs to themselves. So if we want to use that elephant to find out how it matches up with the Jurassic Park or Jurassic World T-Rex model, we can see which one it matches the best with, because those models come in different sizes too. In fact, I can show you right here. That's one size model Jurassic World T-Rex, and then here's another. Now, if we wrap those in plastic and tape and we submerge them, we're going to displace some water, right? And then we can compare that displacement with that 3.4 pound displacement that elephant did. And we can see if this matches up the size range displacement that it would naturally, based on what they think this thing would weigh, or this one, or even a larger model of the T-Rex that they also have made, especially that super articulated one. That's a real big one. So we're going to be doing that in the future, but right now I just wanted to make sure that we see the difference in the math of how things were done with GL1 and how things are done with Dr. Sasparilla. All right, I'm signing out. Thanks for watching.